This is R.D. Sharma Solution Class 12th Algebra of Matrices. We are taking the MCQs, multiple choice questions. If A is equal to this matrix, then A square is equal to. Just multiply A with A and let's see what comes out. You have this 1 0 0 0 1 0 A B negative 1. Multiply it again with this one only 1 0 0 0 1 0 and A B and negative 1. Okay, so what will be the result? See, 1 into 1 is 1, 0 into 0 is 0, 0 into A is 0. So first row with second column, again everything will be 0, 1 0 0 1 0 1 0 0 B 0. Third also same thing. So when you multiply first row with the last column, you'll get 0. Okay, so it is coming like a unit matrix, but we have to just see the second one. 0 0 1 0 0 A 0. Now this middle one, second row with second column, 0 into 0, 1 into 1 1 and 0 into B 0. So it is very clear that it is going to come as unity matrix. It is unit matrix, or you can call it as an identity matrix. This is nothing but I3, identity matrix. If A is this, then A raise 4n equals. So you have to be very clear about the complex numbers, because in complex numbers, this I square is equal to negative 1. So we'll use it here. Either we will go along with I till the end, or we can just change I square equals negative 1 wherever, from the start actually. Okay, so there is a repetition here, and finally something will come which will be multiplied. If multiplied by itself, it will come again. So that is, you have this A and this is also A. So A square we are taking, I 0 0 I. This is I 0 0 I. So I into I is I squared, and then 0 into 0 0. So leave it. Now first row second column, I into 0 0 and 0 into I is 0. So it will come 0. So this will be the pattern. Okay. Now second row and first column, 0 into I 0, I into 0 0. Now 0 into second row last column, 0 into 0, I into I square. So what do you get? See, I square is negative 1, 0 0, I square is negative 1. This is your A square. Now what will we do? We will find out the A cube. A cube is A square into A. A cube is A square into A. So we will multiply this A square, that is this result, with A. So whatever we got, that is, I replaced I squared with negative 1. Okay. So minus 1 0 0 minus 1 multiplied with A. That is the original matrix. I 0 0 I. So now it's very clear what we are going to get. It will be simply I into minus 1, I into minus 1 in the diagonal. That is, this I into minus 1 and 0 and 0 will give you 0. Here also minus I. This is just, we know because we have already done one part. So A raised 4 is what? Again multiply A cube with A cube. Otherwise you would have done A square into A square also. That is also possible. But A cube into A, rather than multiplying 3 times A square, A cube and A4, you could have done A4 as A square into A square. So minus I into I here, so minus I square, and in the second part of the diagonal, even minus I square. I square is minus 1. Just put minus 1, minus is plus, so 1 0 0 1. Now this is A raised 4n. So it can be written as A raised 4 to the power n. But what is A raised 4? It is an identity matrix. So when you take the identity matrix and you multiply it any number of times, identity matrix will give you results same as the identity matrix. Okay. I square, I4, I10, I50, doesn't matter. You will always get an I. Okay. So this is your identity matrix, I. The answer is C. If A and B are two matrices such that A, B equals A and B, A equals B, then B square is equal to. So this B, A and B, multiply both with B. So I am multiplying B with both of these. Right hand side B square. AB is equal to what? In place of A dot B, you can replace it by A from here. And now BA is equal to B from the second one. So B is equal to B square. Please remember, because the question is coming, we are going to utilize it. So B is equal to B square. Here again, same thing we have to do. Because AB is equal to A and BA equals B, and A and B are square matrices. So B square equals B, we have already just now in the previous question, we have proved it. Because AB is equal to A, BA equal to B. And just we saw B square equal to B. Now whether A square is equal to A or A square not equal to A, that we have to see. That means A and C are the correct option. It can be only A and C. It cannot be now B and D, because we have just seen in the previous question. B square is actually equal to B. It is not equal to. These options are incorrect. Now here, AB, we are multiplying A, means in the first equation. So because we need A square. So we have A square. This is ABA. So this, you can write AB as A. No, you will get A square. So it will not work. So in place of BA, you can write B. So in place of BA, write B, because BA is equal to B. So it will be AB equals A square. What is AB? AB is also given as A. AB is A. So A equals A square. So B square is equal to B and A square is equal to A. So please remember this also, because we are going to utilize it in this question, this one. If A and B are two matrices such that AB equals B and BA equals A, then A square plus B square. Okay. See, A square was equal to A, we just saw, and B square is equal to B, we just saw that. So A square plus B square is what? A plus B. Okay. So just have to, don't worry about the left and if you really want to do it, you can do like this, which I've given. Okay, this raised to power k is identity matrix. Then the least positive integral value of k is, means for that value of k, when this left hand side will become an identity matrix, we have to find when it will become an identity matrix. So this will not come in MCQs, because it will take a long time. It is actually a 5 marks question, but still we are going to do it here. But I'll show you how to do it one by one, because doing it will take a long time. So I hope you are comfortable with the matrix multiplication. So when you take the A square, you have to multiply A with A. That is, first row, first column I am multiplying. Cos 2 pi by 7 with cos 2 pi by 7, cos square 2 pi by 7. Minus sin 2 pi by 7 and sin 2 pi by 7. That is going to be minus sin square 2 pi by 7. So this is how you have to multiply first row with these two columns of the next matrix, and second row with the two columns of the second matrix, and just write what you are getting. Now what do you get here? You have to use the trigonometric equations, because cos square theta minus sin square theta is cos 2 theta. Cos 2 theta is what? Because theta is 2 pi by 7 here. So it will be cos 2 into 2 pi by 7. That is going to be cos 4 pi by 7. So this is the catch. Everywhere you have to use this. And what about 2 sin theta cos theta? 2 sin theta cos theta is sin 2 theta. Sin 2 theta. So sin into 2 pi by 7. So sin 4 pi by 7 will come. Right? Please keep the sign like that, because sign will also come negative, positive like that. But these are the equations you have to use. Now A cube will be A square into A. Why we are doing A cube? Because the question is saying to check each and every of them. So we'll multiply this. When you multiply, I hope you'll be able to multiply properly. Then there will be an equation we have to use. That is cos A cos B minus sin A sin B will come. If you take negative from here outside. And then we have the sin A cos B plus cos A sin B. So you have to write cos A plus B and sin A plus B in place of cos A cos B minus sin A sin B and the other equation. Now A raised 6 because A4 is already done. In the options, I am taking the options. 3 I have checked, 4 I have checked. Now let us check for 6. A raised 6 can be easily done by A cube into A cube. Right? So let us multiply A cube with A cube. What do you get? So this A raised 6, when you multiply, you will get again a matrix, and we have to apply these trigonometric equations again. It can be this cos A plus B, sin A plus B, or cos square theta minus sin square theta like this. Now, I hope that A6 you have done. Now multiply it again with A, because A raised 7 also we have to check. When we do this finally, A raised 7, you will see, because one time this has come, 12 pi by 7, all these numbers are normal. But 14 pi by 7, when you divide 14 by 7, it will be 2 pi. Now cos 2 pi has certain value which is actually equivalent to the answer, because cos 2 pi is cos 180 degree. Cos 180 degree is equivalent to cos 0 degree. The sign, if I don't take the sign into consideration. So 1 will be there. And sin 360 degree, sin 0 degree, sin 0 is 0. So it is an identity matrix. So this matrix to the power 7. So K has to be 7. So that you get the identity matrix. So you have to check it for 3, 4, 6 and 7. That is why we didn't check for 5, I guess. If the matrix AB is 0, then we just see that when we are multiplying two numbers, what can happen? Either one of them is 0 or both of them are 0 in normal terms. But when we are dealing with matrix, the two matrix cannot be 0. They have some value, but still the multiplication or the matrix multiplication can give you the result of 0. For example, A is 0, 2, 0, 0. This is our matrix. B is 1, 0, 0, 0. They both are not null matrix. But when we multiply, it's going to give us 0. That is the null matrix. Okay. So if the matrix AB is 0, that is not necessary that either A is 0 or B is 0. A is given like this. What is A raised n? A raised n. See, this matrix, if you take A common, it will be simply the identity matrix. And when you take the identity matrix to the power n, it will only come as identity matrix. But the A you have taken outside, that is the scalar, it will be A raised n. So ultimately it will be the C part, answer C part. But I'll show you. This is A, this is a scalar matrix. So we'll do it properly, but I'll give you a trick here. Just take A outside. I'll show you that just now. So when you multiply this, A 0, 0, 0, A 0 and 0, 0, A. All other will be 0. Only the diagonal part will become A square, because A into A is A square. 0, 0 is 0. 0, 0 is 0. Limit. Now first row, second column. A into 0, 0, 0 into A, 0, 0 into 0, 0. Now first row, third column. A into 0, 0, 0 into 0, 0, 0 into A, 0. So there is a proper analogy and proper pattern. Now second row with the first column. 0, 0 into A, 0, A into 0, 0, 0 into 0. Now second row with second column. 0 into 0, 0, A into A squared. And 0 into 0, 0. So this is what you are going to get. A square in the diagonal. So when you take A cube, it will be A raised 3. When you take A4, it will be A raised 4. A raised n, it will be A raised n. Okay. So you can just directly write C. Just take A common, and that is going to be identity matrix to the power n. That will come again. If A, B are square matrices of order 3, A is a non-singular and A into B is a null matrix, then B is. See, non-singular, singular we have not discussed. We are going to see in the determinants. But I'll give you a hint. Singular matrix and non-singular matrix, if the determinant of the matrix is 0, then they are called as singular and non-singular. Okay? If it is singular, that is the determinant has to be 0. So if A is a non-singular matrix and the determinant of non-singular matrix is non-zero, because as I said, a singular matrix, the determinant has to be 0. So B has to be a null matrix. If B is not null matrix, you won't get A, B equals 0. Okay? So the answer here is a null matrix. Let me tell you again. Since A is a non-singular matrix and the determinant of non-singular matrix is non-zero, that is, it has some value, B has to be a null matrix. So we have done question 8 like this, A raised n. Same thing we are going to do here. See, this is a simple, there is a simple trick. Take n common from here and that will be identity matrix. And when you multiply identity matrix with any matrix, that very matrix will come. But since we have taken n common, this will get multiplied with matrix B. Even if you do the proper matrix multiplication, n into A1, 0 into B1, 0 into C1, and A1 will come. You can try out any of the combination. Okay? Because in this first row and second column also, n A1 will come, other will be 0. Right? So what I am trying to suggest here is, this multiplication you can do, you can find out the answer. But the trick here is, the first matrix you can take n common, that will be identity matrix. And we know when we multiply anything with the identity matrix, that thing will come. And since we have taken n outside, it will get multiplied with every other element inside. So the final result will be simply n into b. That is, I am taking n common. This is the identity matrix. Because you can take n common. This is a scalar multiplication. Now take the B matrix, multiply. B with I, that is identity matrix with any matrix will be B, this same matrix B. N into B, that will be the scalar multiplication. So n into B will come. Okay. So everything will be multiplied by n. Right? N into B is the answer. Okay, this question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.